Welcome everyone. In this video I'm going to build a variable power supply. So the reason why I built this is because I got a few old laptop power supplies. Something like this. It's an old Lenovo power supply. It has 20 volts as an output voltage and it can provide 4.5 amperes, so 90 watts in total. And it has this big DC jack, which is suitable for laptops, of course. So I got this power supply and I cannot use this as it is, and 20 volts is usually too high for my projects. So it makes sense to use a DC-DC converter and make this this power supply into a variable power supply. So the topic of this video will be this transformation basically, and I have already assembled the system which I will use to make this into a proper power supply. So I will guide you through all the wirings and why I set these things up, and then I will put everything in an enclosure and you will see the final result, of course. And the core of this variable power supply is of course a DC-DC converter, and now I picked another one which I usually use. So this is my regular one which I use, but this is like too high performance. I will not make use of it, so I have a smaller one, but the basic principles is the same. You have an input and an output terminal here, and then you have two potentiometers. If you hold the power supply or the DC-DC converter, sorry, like this, then the bottom potentiometer is for the voltage and the top potentiometer is for the current. And what I will do with this is that I will remove these potentiometers. I notice the polarity of the potentiometers because it's important, and then I will replace them with the same value but different style potentiometers, so I can put these potentiometers on the front panel of an enclosure. So I will change that, and then there will be another added component, which is this guy here. And this is nothing else, it's just a voltmeter and a power meter in one simple enclosure. And it has 5 wires. I will show you the wires exactly, but as you can guess, the thick wires are used to measure the current. So in fact, you use these thick wires to connect your load to your power supply, whatever you use. And then the yellow wire is used to measure the voltage, which is in your circuit. And these two thin black and red wires are used to provide power supply for the circuit itself. So what I will basically do, or I have already done it here, is that these two wires which are providing a power supply for this circuit will go to the input of this DC-DC converter, because this can run at 20 volts easily. So at the input of this DC-DC converter we have the 20 volts, which is coming from this guy, and then the yellow wire goes to the positive output of the DC-DC converter. And then we have these thicker wires, and how I did this is basically I connected this in series with the load, which in this case is a Peltier cooler. So then I will also add a few banana plugs to the enclosure. So this is just to make the connections easier, and this banana plug is nice because if I can unscrew it, I can show it that there is a hole here, so I can just drop the wire there and yeah, fix it by screwing this back. So this is nice. And then I will also have a, let's say, main switch, which will turn the input for the DC-DC converter on or off. So basically we isolate the wall circuit, which we have here, from the laptop power supply. So that will be the whole thing. And then yeah, I have just a tiny enclosure, so I will use this. It can fit everything just fine. So I will use this enclosure to finalize everything and make it more useful. So then let's go through the circuit here, and I will tell you step by step what we have. So if the circuit is aligned like this, then we have the following things. So on the top two connections, so here, the top two, we have the positive output and the negative output, and then we have the negative input and the positive input. So then what is happening in the positive input part is that through two wires I connected a power supply, and I just use my laboratory power supply, but it is set up to the same parameters as the laptop power supply, so 20 volts and 4.5 amps. And then I also connected this circuit, and as I said, I just connected the power source for this. So what we have, positive goes to the positive and negative goes to the negative. So therefore we already used these two guys here. So I think that's quite easy to follow. And then we have the output on the top. So let's start with the positive output. So the positive output of this DC-DC converter, first of all we connect this yellow cable there, because that is used for the voltage measurement. And then we connect also the positive side of our load. So now in this case is the Peltier cooler. And then what you should imagine here is that you follow the flow of the electrons, but backwards of course, but you follow this process as it would be a water. So in the positive output, the water comes out, and then it goes to our load. So then it goes through the load and it comes out. And then the black wire here is actually connected to the red wire here. So then then the flow continues, goes into this device, and then it comes out from the device, and then it goes back to the negative output of this DC-DC converter, and that closes the whole loop. And that what happens here, with a small exception, that I put this now current meter in series with this circuit. So technically what happens is that the wire comes out from the positive output, goes into the device, and then the black wire comes out from the device, and that goes into this multimeter here, which is used as a current meter now. So it goes in through the red wire, goes in, black wire comes out, and then the black wire is connected to the red wire of this. So technically the positive input, let's say, of this device. So then a red wire goes in, and then the black wire of this device comes out, and that black wire goes back to the negative. So I hope that this makes sense. I don't really want to make a drawing for this very simple circuit, so instead of that I could explain this in 3 minutes. And then I have another multimeter here. I will just use these probes just to measure the output voltage. So at the end what I want to do here is I just want to confirm that I see the proper values on this display. And after that, if that is working well, then I just show you that I can change the current and the voltage with these potentiometers. And then I just clean up everything, put everything in an enclosure, and we are done. So I just close the circuit here just to have everything connected, and I turn on the meters, and now I turn on the power supply. So now the potentiometers are turned down, so the output voltage and current is relatively low through this Peltier cooler. So what we see here is that this thing measures 0.55 amps as the current which is flowing through this circuit, and here we see 0.55, and that's pretty much okay for me. I don't want a very high precision, I just want approximate values. And then we measure 2.11 volts, so let's see what this multimeter sees. And it's almost the same, so 2.11, so that's pretty much fine, I would say. And now I will change the potentiometer a little bit, so we will see what happens. So you can see that the voltage went up, and of course the current followed it because of the Ohm's law. So I haven't put any limit on the current, so as I increase the voltage, the current will follow it. So we see 4.4 on the multimeter and 4.3 here, and 1.11 here, and 1.13 here. So it's pretty much okay. So I would accept this, and we can see that this works. So we are satisfied with this. So the next steps here is to replace the potentiometers on this thing. So I will do that, and I will continue the discussion. So I have removed the potentiometers, and I started to put in the wires, but then I realized something that I must discuss, and there are two things that we have to make sure that we know properly. So first of all, we have to know the polarity of these potentiometers, because in this case we know that the Viper is in the middle, and that's very nice, but sometimes when you want to use your own other potentiometer to replace these things, you might have the Viper on the side. So therefore you don't solder it obviously in the same order as you would solder this into the board or into the board through the wires. So therefore we want to measure this quickly. So I just demonstrate this to you. So you want to measure the resistance, and first of all you check one side and for example the middle, and you see that now we have like 9 kiloohms. And then I start to turn the Viper or the potentiometer, and you see that the value changes. So therefore I measure between the Viper and one of the poles, and then depending on the pole, either the value decreases or increases when I turn it in the same direction. So then we know that yeah, obviously this is this has the Viper in the middle, but what happens if we want to use our own potentiometers? So once again we select two legs, so I just select the two side legs. I know that this is not good. So what you want to see is that when you connect to the two legs and you don't see any change when you rotate the knob, then you know that you are measuring the two sides. So basically the, let's say, positive and negative sides of the potentiometer. And therefore the leg which is not measured, which is now the middle leg, is the Viper. So this has the same output. And you see the nominal value of the potentiometer, which is the second thing that I want to discuss. Here, this is like a 10 kiloohm potentiometer, yeah, more or less. So you can see it. And now I just show you that we can change the value, of course. So it changes nicely. And why this is 10 kiloohm? Because this is also 10 kiloohm. So the second thing is that it's not only the layout of the pins, but you also have to make sure that you are using the same values, otherwise your circuit will not work. So this is also a 10 kiloohm potentiometer. And why I emphasize this is because this other thing, this SZBK07 DC-DC converter uses 100 kiloohm, but the potentiometers look the same, but that has a different code on the top. So keep in mind that you should use the same values. So this one uses 10 kiloohms, so we will use 10 kiloohm potentiometers. So now I halfway prepared everything, so I will just continue the soldering, and I will clip these legs. I don't need them, and I just push the wires in from the back and connect them according to the layout. So once I'm finished and set up the test circuit, I will get back to you and follow up with the details. So I finished with the soldering. Once again, these are 10 kiloohm potentiometers, both of them. So I connected them as I should do. So positive, Viper, negative, positive, Viper, negative, if you have this kind of alignment. And now I haven't turned on the power supply, but I connected the voltmeter or multimeter to the output. So I'm just measuring the output voltage just to confirm that I can change it with these new potentiometers. So I turn on the power supply now, so the LED should light up. LED is on, and we read the minimum voltage which is coming out from the output anyway. So you cannot go below that because of the nature of this DC-DC converter. But then we already see that the potentiometer works, because if you connect the wrong potentiometer, then the voltage will be the maximum voltage which is on the output of the DC-DC converter. So technically you are reading the input voltage without the regulation. So now if I start to turn this, then the value should change, and as you can see, it changes, so it works. And then now this would happen without a potentiometer. So once again, I just show you that I just turn it randomly, and then it works, and it's relatively fine. So I try to go below a certain value, and you see that it works, and I can change it in the, let's say, a few 10 of millivolts if I'm careful enough. But of course this is not a multi-turn potentiometer, so that would be a better choice, but I just don't have it right now, so this is what I have to work with. But for me this is just fine, because for me it's enough to have the control over, let's say, 1/10 of a volt. So yeah, this is more than enough. So this works. So now I will put everything together in a box, and we will see if it still works. So I finally assembled the box, and what you see here is, yeah, the power supply part, and I put together some multimeters with some load just to test the box once again. So if we start from the beginning, then we have this laptop power supply, which is capable of providing 20 volts at 4.5 amperes, and then this cable goes into this box. It's just a simple connection, and it goes into this switch. So with this switch you can isolate the rest of the circuit from the laptop power supply. Essentially you turn off everything. So then on the other side of the switch we have the DC-DC converter that is somewhere here in the box. And then the DC-DC converter is connected to these two potentiometers. So these are the two, once again, 10 kOhm potentiometers. One is responsible for the current setting, and the other is responsible for the voltage setting. And these two values are displayed on this small LCD. And finally, we have the output here. Now I just use this gold or copper plated banana plug. Yeah, this is used for speakers, but it's perfect for me because it has a hole, as you can probably see it. So I can, yeah, put in the cables and then just turn this against the cable so it's gripped. So yeah, we have the output. And that's all about the box. And what we have here as the rest of the demonstration is this multimeter will measure the current passing through the load, which is a Peltier cooler. And then with this multimeter, I will be using these two probes just to probe the output voltage. And the purpose of these two multimeters is to compare the value displayed on these guys and displayed on this guy here. So what is happening here is that the positive side comes out from the positive output of the power supply box, goes into the Peltier cooler, negative side comes out, and then it goes straight in this multimeter here. So we are using it as a current meter because it's connected in series with the load, as we should do it. And then black cable comes out from the multimeter, and it is connected to the negative output of the power supply. And with this we close the circuit. So now we have nothing else than just testing this thing. So this is in current mode, and this is in voltage mode. I think you can see the displays pretty well. So now I just plug this in, and nothing should happen because now this is at 0. So let's see. So this is now plugged in, and now I turn this on. So before I turn this on, I have to tell you that here the minimum output voltage, which is always present on the output of this converter because of the nature of this converter, roughly 1.25, 1.3 volts should show up, because now I set the potentiometers to the minimum. So yeah, we have this 1.12 volts, and of course I can confirm it, and 1.2 watts, so that's pretty nice. And since I already have the load connected, then we see some current flowing through the circuit, and that is 0.26 here and 0.28 here. For me that's pretty much acceptable, because I just want to get sort of informed about the output voltage and stuff. So now I increase the voltage, and of course I have to follow it with the current, because if I don't let a certain amount of current flow, then the voltage will not be increased. It's Ohm's law. So now you see that we have 8 watts and 2.45 amps. The current is almost the same, and then the voltage is also very close. So as you put a bit more load on this power supply, it seems like that this thing becomes more precise. And of course this is a Peltier cooler, so it became quite cold. So yeah, it works, and as you can see, it works with a quite okay precision, at least for me. So I just cut these things and I turn this off. So this works very well, and this was a nice way to recycle a power supply for a laptop, which would have been thrown away otherwise. So I'm very happy that I could save this and make it into something useful, because usually I use these kind of power supplies for powering my projects, but sometimes one is not enough, or two, so it's good to have multiple of this, and it's quite a nice performance, so it's good to have it. So basically this was the whole video. It was more like a demonstration that if you have these things around, you can do something cool with it. And I will put my drawings and everything on the website, so you can understand it maybe better, how this voltage and the current meter is connected to the rest of the circuit. So I will publish them, publish the drawings on my website, so please visit my website. And basically that's all. So I hope that this was useful to you. I hope you learned something, and see you in the next video.